Okay. Hello everyone. This is another video on electromagnetic theory. Here we'll be solving previous year questions of GATE for electromagnetic theory. So, so we'll be solving GATE PYQs of EMT. Okay. So very interesting session. So continue with number one question. First, let's solve some questions on polarization that we have done in the previous sessions. Okay. So question is electric field. I don't have it in the printed form, so it's electric field of an electromagnetic wave. Electric field of an electromagnetic wave is is given by is given by E vector. Sorry, E vector is equal to 3 sine kz minus omega t uh, x cap plus 4 cos kz minus omega t y cap. Okay, the wave is what? Which kind of polarization is there? Which kind of? I won't give the options. Which kind of polarization? Okay, and at what angle? Okay, at what angle? That's it. So, see, electric field of an electromagnetic wave is given. So, electromagnetic wave is given as how much? Answer. You can take your time. You can take your time, 2 minutes, 3 minutes. You can pause the video also if you want. So, electric field is given. Electric field is given how much? Um, 3 sine. If it is given 3 sine um, kz minus omega t, 3 sine kz minus omega t x cap plus 4 cos kz minus omega t y cap. Okay, so we have seen if what are the conditions of polarization if phase is 0 pi 2 pi etc. It is linearly polarized, right, or plane polarized. But if the phi is pi by 2, 3 pi by 2 etc., it is what? It is circularly polarized. Circularly polarized. All right. So, um, here what is happening? See, and no. Again, I made a mistake. Circularly polarized means we have to check the amplitude also. Check amplitude. Okay. If the amplitudes are same, then that is circularly polarized. If they are not same, they are elliptically polarized. They are elliptically polarized. Okay. So, E is equal to 3 sine kz minus omega t x cap plus 4 cos kz minus omega t y cap. So here see, one is x cap, one is I cap. So the phi is obviously 90 degree, pi by 2. And after pi by 2, see, check the amplitude. First one is 3, second one is 4. So they are not same. That means this is what? Elliptically polarized. They are elliptically polarized. Alright. So they are elliptically polarized first. That is the first answer. Okay. And So how to know whether it is like clockwise in clockwise direction or anti-clockwise direction? How to know that? See, we did that in that previous section. That is, we have to find at omega t is equal to 0. What will be the magnetic electric field? Omega t is equal to 0. E will be what? Sorry, Ex will be like x component will be 3 sine kz I cap, and Ey will be 4 cos kz j cap. Okay, now z also 0. So Ex will be what? Ex will be 0. Ey will be 4j cap. Okay. Now omega t is equal to pi by 2. Omega t is equal to pi by 2. So omega t is equal to pi by 2. Ex will be how much? Omega t is equal to pi by 2. Ex will be what? 3 sine. Wait, just wait. Hmm. Yeah, 3 sine kz minus pi by 2. 3 sine kz minus pi by 2. Okay, which is 3. What? Hmm. Okay, 3 sine kz minus pi by 2. Right, which is 3 cos kz, right? Anyway, Ey will be 4 cos kz minus pi by 2. Okay, so if you see now z, I will put z is equal to 0. So here Ex will become what? 3 sine minus pi by 2, that is minus 3. And Ey will become what? If I put z is equal to 0, cos pi by 2, that is 0. So this is 3 I can. So see, in at 0 angle, okay, at 0, like if I draw the diagram, x, okay, so like at 0, if you see at omega t is equal to 0, Ey is 4j cap, and at omega t is equal to pi by 2, Ex is there at minus 3 I cap, isn't it? So the direction is like this, from 0 to pi by 2, right? Omega t is 0 to pi by 2. So first omega t is 0, this is 4j cap, pi by 2, this is minus 3 I cap. So from this to this 4 I cap to minus 3. So this is which direction? This is your anti-clockwise direction, isn't it? This is your counterclockwise or anti-clockwise direction. So elliptically polarized in anti-clockwise direction. All right, is it clear? Yeah, this is the question. All right, again a very good question. It can come for 2 marks. All right, yeah. Next question. Next question. Next question is question number 2. That is, electric field of an intermediate wave is given. Okay, is equal to 3 sine k z minus omega t x cap. Wait, which is sorry, I'm very sorry. Hmm, question number 3. Write down the question. So a light beam of intensity I naught is falling normally on a surface. The surface absorbs 20% of the intensity, 20% of the intensity and 20% of the intensity and the rest is reflected. The rest is reflected. Okay. So the radiation pressure is on the surface is given by dash. Okay. Okay. So the it should be dash I naught by c. You have to write the answer in terms of I naught by c. Okay. Try the question. Light beam intensity I naught is falling on normally on a surface. Surface absorbs 20% of the intensity. Rest is reflected. Okay. So 20% is absorbed. Rest is reflected. Radiation pressure on the surface. So if you see radiation pressure is what? Radiation pressure. I can write radiation pressure. Radiation pressure is equal to I naught by c minus what? What will I write here? See, 20% is absorbed. How much is reflected? 80%. Okay, 80% is reflected like this in the opposite direction. So I can write it as I naught by c minus of 0.8 I naught by c. Okay, this would be what? I naught by c plus 0.8 I naught by c. That will be a 1.8. This is your radiation pressure. Okay, the answer is 1.8. Right? Yeah. Okay. Next question. Next question is you are asked. Question is number three. Electric field is given EZT, Z function of Z and T. You can E naught cos kz minus omega t, kz minus omega t I cap. Okay. Pointing vector will be how much? That is the question. What is the pointing vector? Alright. So EZT is equal to E naught cos kz minus omega t I cap. Okay. So what will be the magnetic field? What is the magnetic field? Magnetic field is 1 by c k naught k vector cross E vector. Okay. So k vector is what actually? Z cap. This is minus. So z will be positive. So z cap cross E naught cos kz minus omega t I cap. Let me write it as x cap. So I 1 by c E naught cos kz minus omega t j cap z cap plus x cap is y cap. This is a magnetic field. So what is the simply pointing vector? The pointing vector S is equal to how much? E cross B by mu, right? By mu naught. Put it. Put E is E cos E naught cos kz minus omega t I cap or x cap cross 1 by c E naught cos kz minus omega t y cap whole divided by mu naught. Okay. So if we simply multiply them, that will be what E naught square cos square kz minus omega t x cap cross I y cap is z cap by c mu naught. This is what this is your pointing vector, right? This is a pointing vector. Okay. Next question will be next question. Question number. How much? Question number will be what? Question number 3. Question number 3. Question number 3 is point charge is placed between two semi-infinite what conducting plates which are inclined at an angle of 30 degree with respect to each other. With respect to each other, the number of image charges is the number of image charges is okay. The answer. See, point charge is placed between two semi-infinite conducting plates. Okay. So what which are inclined at an angle of 30 degree. Okay. With respect to each other. Number of image charges. So the formula for it is number of image charges n is equal to 360 by theta minus 1. So 360 by theta is 30 degree minus 1, that is how much? 12 minus 1, that is 11. This number should always be odd. Okay. This should always be odd. Number of images should always be. Yeah. So will come for 1 mark. Okay. It will come in NAT numerical answer type question. Yes. So don't leave these questions. They're the easy ones. Okay. Next question. Question number 4. The intensity of a laser in free space is 150 milliwatt per meter square. Okay. Corresponding corresponding amplitude of the electric field of the laser is of the laser is. Intensity of a laser in free space is given. So you are given what? You are given 150 milliwatt per meter square. So 150 into 10 to the minus 3 watt per meter square is given. That is it. Corresponding amplitude. Amplitude is asked. Amplitude of what? Electrical. That means E naught. Okay. So we have to find a relation between intensity and amplitude of electrical. What is it? So I is equal to what? Half C epsilon naught E naught square. So half into 3 into 10 to the power 8 into 8.85 into 10 to the minus 12 E naught square is asked. I is given as how much? 150 into 10 to the power minus 2. That's it. This is what we have to solve. Okay. Yeah. So questions like this only will come in exam. Alright. Like very easy numerical type answers. Okay. Math type. Okay. Okay then. So that will be it for this class. It will be a short. It was a short session. We'll be solving more questions in the upcoming sessions. Okay. Thank you very much.